Hi, you guys. It's Miss All Day. I hope you're having a good Thursday. Let me pull up some information here for us to look at. All right, this first thing I'm pulling up is the agenda for today. So today is day 9, April 9th. It's Thursday. We're going to do our 11-7 lesson. We're going to do some problems, some got it problems, and then we'll be done with the notes for today. And then you'll do your homework assignment, and then you'll do your upload. So thank you so much for doing such a good job doing your uploads. On Friday, it's really a school holiday, so you could take the day to catch up. This is what I'm looking is that at the end of every week, when you get done with your weekend, Sunday evening, everything should be updated by Sunday evening. So, for instance, for last week, you had days 1, 2, 3, 4, 5. So, April 3rd was the Friday. So, the 4th and the 5th was Sunday. So, Sunday by midnight, everything for week 1 should have been completed and uploaded. So, for this week, we have week 2 going on here now. You guys are doing such a great job. So, you have 6, 7, 8, and 9. Okay, because we have Friday off, you could use it as a catch-up day. So by the time you get to Sunday, which will be April the 12th at midnight, everything for week 2 should be done. So when you get ready for your lesson for Monday, on Monday, April the 13th, you're going to do a chapter test. Of course, it's open book. So here are the textbook pages. You're going to write it yourself. You're not going to write like on a worksheet page. You're just going to do it on notebook paper. You're going to upload the test by midnight, April the 13th. Now, you're welcome to do it before then if you want. Okay, and then I'll have some new lesson plans up for you probably this Friday or at least by Sunday evening. All right, so let's go ahead and go into today's lesson. Go ahead and title it. Today is April the 9th. Okay, we're on our last lesson for chapter 11, area and volume of similar solids. All right, similar solids. Similar solids have the same shape and all of their corresponding dimensions are proportional. That should sound familiar because when we did similar figures, like two triangles are similar, they had to both be triangles, of course, okay? And all of their corresponding dimensions had to be proportional. Their angles had to be congruent. So that's just a little refresher on similar figures. We're doing similar solids. So we're talking about 3D objects now. The ratio of corresponding linear dimensions of two solids is the scale factor. And you know about that as well. Scale factor. The ratio of one solid to another, or back when we were just doing shapes, the ratio of one 2D shape to another. But we're doing solids. We're just going to apply what we already know to the solids that we've been working on. All right, so number 1, are the two rectangular prisms similar? So that's good. They're both rectangular prisms, so they're the same solid. Not the same shape, though. If so, what is the scale factor of the first figure to the second? All right, so I'm going to call this length and this length. So I'm going to put 3/6. So that's small length over large length. All right, I'm going to call this width and width. So that's small width over large width. And then I'm going to call this, you could either call it depth, or I could have actually, I'll do this in blue so you know where I'm at, called these height. That might have been more appropriate. And then called the 2 and the 4 length. Okay, so we know that a 3D figure has length, width, and height. All right, so we're going to do the length 2 to the length 4. All right, now let's reduce these. And you see that every single one is 1/2. All right, well, we know they're both rectangular prisms. And so if the scale factor is the same for both of them from one to the other, meaning that they're proportional, So yeah, are the rectangular prisms similar? Yes. All right, so let's go ahead and answer A. A, we're going to say yes, they're similar. We're going to say the reason why. The sides are proportional. All right, and then for B, it said, what is the scale factor of the first figure to the second? So that I did the first, and then I did the second dimensions. So we have it right. So our scale factor is 1/2. You can either write it like that, or you can put equals to 1/2 if you want. All right, let's check out the next picture. Let's do purple. We'll let this be height for the small and height for the large. So that's what, 2/3? All right, we'll let this be width of the small and the width of the large one. All right, and then we have length of the small one and length of the large one. All right, so let's reduce this one. All right, now you're already seeing, wait a minute, even though they look similar, are they actually similar? And our answer would be no. There's a couple of ways you could say this. We're going to say the sides are not proportional. And how do we know that? Because the scale factors have to be all the same if they were proportional. So for the second part, what is the scale factor? There's not one. You could put, for B, you could say that 2/3 is not equal to 1/2. There is no scale factor if you want to put that. You don't have to. We already said no, so you don't really have to answer that second one for this problem. All right, let's apply this using the cylinders. All right, so they're the same 3D shape, so that's a good thing. So there's a chance that it can be similar. Now, what we're going to look for when we're looking at the cylinders is we're not going to look at length, width, height like we did the rectangular prisms. We're only going to look at the radius and the height. Okay, so the radius for this first one, oops, sorry, I didn't mean to scribble, is 6, and the radius for the second one is 5. The height for the first one is 12, and the height for the second one is 10. All right, so let's write that. Let's do radius of the large one over the radius of the small one. Now, why am I doing that way? Because it says the first figure to the second. So we're doing it what they asked. All right, and then I'm going to do the height of the large cylinder to the height of the smaller cylinder, and I have to reduce this. So I'm going to divide by 2. That's going to be 6/5. Hey, they're the same. We're in business then. So we're going to start with A. Are the cylinders similar? And we're going to say yes, because the sides are what? Right, they are proportional. All right. All right, the second thing, B, if so, what is the scale factor of the first figure to the second? So the scale factor is 6/5. Now, if they don't tell you what the scale factor is, you still do the first one first and then the second. But they could say, what's the scale factor from the second to the first? And that's when you would write 5/6. But they didn't ask us that. They have to specifically ask us that for us to write it that way. All right, this right here should be very familiar. The scale factor of two similar solids. So let's see, the scale factor of, let's say, the length of one figure to the length of another is A/B. The perimeter of one, now I'm not talking about a 3D figure right now, I'm talking about a 2D, I'm just reviewing. The length, the perimeter of a 2D figure over the perimeter of a 2D figure. Then we could say area, the area of a 2D figure over the area of a 2D figure. That would be A squared over B squared. All that should be similar. These two right here, A/B, is the scale factor. We've done this for similar 2D figures. If the scale factor of two similar solids is A over B, if that's what the scale factor is, then the ratio of their areas, so this is going to be the area ratio, is going to be A squared over B squared. That makes sense. Area is square units, those are squared. The ratio of the volumes, this is the new piece, will be A cubed over B cubed. So that's just the new piece. Everything else really so far, we've kind of already known. All right, finding the scale factor. All right, let's look at this one. The square prisms at the right are similar. Okay, they're already telling us, hey, these are similar. What is the scale factor for the smaller prism to the larger? So we're going from left to right. Okay, smaller to larger. All right, so the first thing we want to do, we want it set up like this. They're giving us the volume. So I'm going to write the smaller measurement over the larger measurement. Okay, so step 2, the volume, small measurement, 729 cubic centimeters, over the larger measurement, 1,331 square centimeters, equals, go back up there, which one's volume? Is it A over B, A squared over B squared, or is it A cubed over B cubed? Okay, so it's going to be the A cubed over the B cubed. Now, I think it was yesterday that you guys had to figure out the cubic button on your calculator. Just to refresh your memory, I don't think it looks like this, just sitting there waiting for you. I'm pretty sure it looks like this on your calculator, where if you want this to be cubic, you have to input a 3, and it's going to tell it to go here. Then push this button, then type in 729, and then press the equals button. And what it should do is it should tell you what number times itself 3 times is 729. All right, so this is what you do. You do the cubic root here, you do the cubic root here, you do it here, and you do it here. Okay, so you're doing it to everything. So I'm going to do the letters first. So the cubic root of A to the third is A, and the cubic root of B to the third is B. That's what I'm wanting it to look like, because look, they asked me for the scale factor. So I'm going in the right direction. So when you plug in the cubic foot of 729, what did you get? You should have got 9. If you didn't, you need to play around with your calculator, because that's the answer you should have got. When you plug in what's the cubic root of 1,331, you should have got 11. All right, so this is our third step. What is the scale factor? So here's our answer. 9 over 11 is our scale factor. All right, example 4. What is the scale factor of two similar prisms with the surface area? Wait a minute. They just did volume a while ago, and now they're doing surface area. So we got to think A squared over B squared. We can't think A cubed over B cubed just because we've been doing volume all week. So it's going to look like this. I'm going to say, okay, I'm looking at surface area, and I'm going to do the small surface area over the large surface area. So my step 2 is, what is the surface area of the large and the small? All right. The small one is 144 square meters. So I'm going to put 144. The large one is 324 square meters. Think smarter, not harder, right? Come up here and you're going to do the A squared over B squared because you're doing surface area. So you're going to set it equal to A squared over B squared. Well, now to find the scale factor, you're going to have to do the opposite of squaring something. And that's doing the square root of something. So the square root of 144 is 12. The square root of 324 is 18. The square root of A squared is A, and the square root of B squared is B. Now all we have to do is reduce that. All right, so our fourth step, we're going to reduce. And this is going to be our scale factor. So 12 and 18 can be both divisible by 6. So 12 divided by 6 is 2, and 18 divided by 6 is 3. So the scale factor is 2/3. Remember, pause me whenever you need to. All right, let's move on to the next section. Using a scale factor. All right, painting. The lateral areas. Now remember what lateral was, and a lot of people get confused with lateral. All it is, you guys, is the sides. It's not the top, and it's not the bottom of it. It's the sides. So like if you go pick up a Campbell soup can and you take the label off, that's lateral. The label is lateral. Get it? Label, lateral. Label, lateral. Probably where they came up with it from. I don't know. I'll let you figure that one out. All right. The lateral areas of two similar paint cans are 1,119 square centimeters and 425 square centimeters. The volume, okay, so this was area, right? The volume of the smaller can, I'll do it in another color, is 1,057. It's the volume. What is the volume of the larger can? All right, well, we can't even go straight into like a squared over b squared equals a cubed over b cubed because that ain't going to work. Those aren't equal. We have to go find the scale factor. So we're going to start off with the one where we know two pieces of information. So our first step is, okay, for the lateral area, I know, and it doesn't really matter which one you do first, but since the bigger one's first, that's the one I'm going to do first. The lateral area of the larger paint can is 1,019. The lateral area of the smaller paint can is 425. All right. Now, that is actually a squared over b squared. Now, in order for me to get the scale factor, which is what I need, I'm going to have to do the square root of everything, just like I did a while ago. All right, so my second step is find out what a over b is. So the square root of 1,019, I really don't know what it is, and we don't want to put a big old decimal. So we're going to leave it as the square root of 1,019. And if I plugged in the square root of 425, that's not going to look so pretty either. So we're going to leave it as the square root of 425 because those are not perfect squares. All right, we found the scale factor. This is good. This right here. This is the scale factor. That's a good thing. All right, next step. We have to figure out, we're going to have to do volume over volume. So I'm going to have to do a cubed over b cubed. All right, so if I'm doing that, then I'm going to take my a over b, which is the square root of 1,019 over the square root of 425, and we're going to have to square the whole thing. I'm not square, I'm sorry, cube, because this is cubed. I didn't mean to say squared. Sorry, you guys. We have to do it cubed because we're doing volume now. We're not doing area anymore. So, in your calculator, you're going to have to do something with that in a minute. But before we move on, there's one more piece of information that we have. Remember in brown up here, we have the volume of the smaller one. So which number is smaller, 1,019 or 425? All right, 425. So that's on the bottom. So we're going to erase this b cubed and we're going to replace it with 1,157. All right, so now we're only missing one piece of information. When we get finished in a minute, I'll do this in yellow. They wanted to know the volume of the larger can. Well, this right here is the volume. This is the larger number, so that's the volume of the larger can. So when we get finished, we're going to have our answer. All right, so what do we do next? Step 4 is I've got to get rid of this divide by 1,157 because I've got to get the a cubed by itself. So the opposite of divide by it is going to be to multiply by it. All right, so step 4, in order for me to figure out what a cubed is, I'm going to have to take 1,157 and multiply it by the square root of 1,019 over the square root of 425. And they're both cubed. So I don't know if you want to write them separately as cubed or what. So this is the deal. You're like, oh my gosh, are you kidding? How am I going to put that into my calculator? All right, so I'm going to lead you through. Let me pull up my calculator. This calculator is not as good as yours. You're going to put in 1,019, and then you're going to hit the square root button. Let's see if I can find the square root button on mine. Yep, right there. So 1,019, and I'm hitting the square root button. All right, that is the square root of 1,019. Now we're going to have to do divided by, and we're going to have to do parentheses. And I do not see parentheses here. Your calculator will have it. I don't know why mine doesn't. I wonder if I jump back over here. I bet I'll lose what I just did. Yep, I lose what I just did. So my calculator on here is not being very nice to me. Okay, so I'm just going to have to lead you through it. So I'm going to write in this nice pretty purple color. What you have to plug into your calculator, I'm going to put below. So pick up your calculator. The square root of 1,019. Press your equals button. Divided by, so press your divide by button, the square root of 425. Now you might have to put that in parentheses. I don't know for your calculator what you have to do. Press the equals button. All right, so now you have this number. This whole thing now, you just found out it was some number. You're going to take whatever that number is, and I'm going to do this in pink, and you're going to cube it. Now, your calculator, you might have a little caret button, and then you hit the number 3, because whatever that number is, you've got to raise it to the third power, or you just might have a cubic button. So whatever that number is that's in your calculator right now, you need to use the caret button and do it to the third power and press the equal sign. So now you have this big pink answer right here, whatever that answer is. You're going to multiply it by 1,157, whatever's in your calculator right now. All right, let me erase this. And while you're doing that, I'm going to go through those steps again. Take the square root of 1,019. Okay, press the equals button. You got that number. Now, you're going to divide it. Go ahead and put this in parentheses to cover our bases. The square root of 425. Close parentheses. Hit the equals button. Take that whole thing and cube it. Press the equals button. Multiply it by 1157. So that should have gave people time to do that. So when you do that, you're going to get that the volume, this is step 5, the volume is 4,295 cubic centimeters. That's a comma, not a period, just so you know. That is our answer. Go back to your question. What is the volume of the larger can? Check. Got it. Now we started out with lateral area and lateral area, but we had to find volume. All right, let's look at this one. Now, look at this one. Now isn't this cray-cray, right? They say, okay, here's the volume of two similar figures, 128 and 250. We're like, okay, well, let's go ahead and focus on that. Volume is going to be a cubed over b cubed. And I'm going to do the 128 first because it was first and the 250 next. All right, I've got to find the scale factor. This always your first step is find the scale factor. If they give you area, but they want you to find volume, find scale factor. If they give you volume and they want you to find area, find scale factor. That's your beginning point. What is the scale factor? All right, so the next thing we do is we have to do the cubic root of a cubed, which is a, the cubic root of b cubed, which is b. Aha, here comes our scale factor. Then we're going to do the cubic root of 128, and we're going to do the cubic root of 250. All right, so we really already have the scale factor. It's right here. All right, so once we have the scale factor, we're going to move on. Now, you could plug that into your calculator if you want, but you're going to get some kind of decimal over some kind of decimal, and it's not going to be very pretty, so we're leaving it the way it is. All right, now, we've taken care of the information we know. We set up the volumes, and we found the scale factor. Next is they want to find the surface area of the smaller solid. Well, they gave us the larger solid. All right, so now we've got to think, okay, if we're finding surface area, right? We're going to do a squared over b squared. All right, so we're going to take this scale factor right here that looks pretty cray-cray already, the cubic root of 128 over the cubic root of 250. And we're going to have to square all that because that whole thing right there, that is the scale factor. So I'm going to use black and put a little 2 up here. I'm squaring it because if this side is squared, then this side has to be squared. You know how it is with your brother or sister. If they get a candy bar, you want a candy bar. No, I'm just kidding. All right, so now go back up to your problem and see, what do you already know? Well, I already know that the larger solid, the area, the surface area is 250. So which one of these numbers is larger, 128 or 250? Well, obviously 250, and it's on the bottom. So that's where you're going to put the 250, which I know you're like, wait a minute, that's kind of weird. Sometimes the area and the volume is the same. It doesn't always happen, but it can. So that was the area of the larger solid, and so this was the larger number, so I put the area of the larger one on the bottom. So now this is making kind of sense. Look, it's just a proportion. We've been doing those for a while. All right, so I want to divide by 250. So the opposite of divide by 250 is multiply by 250. So I'm going to multiply both the left side and the right side of a proportion by 250. So when I do that, this cancels out. All right, I'm going to go way down here for number 4. This is what I have so far. I have that a squared, which is the surface area that I am looking for, equals the cubic root of 128 divided by the cubic root of 250 being multiplied by 250. Now, you always want to put your radicals into your calculator first. So I'm going to lead you through this because I think I actually left my pink calculator that can do this at the school. So I'm going to lead you through it, just guide you through it, okay? All right, so the first thing you're going to do is you're going to plug in the cubic root of 128. Now, this is the button you're looking for. So you type in 3, and then when you hit this button, it puts the 3 right there where the X is. Type in 128. Press the equals button. All right, next step. So you typed in this, and you press the equals button. Now do the divide sign. Hit the divide button. Do parentheses. Do the 3 and that symbol again, the cubic root of. Do 250. Close the parentheses. Press the equals button. It's going to tell you what this whole thing equals. Once you get that whole thing, I'm going to go over here in yellow. Once you get this whole piece here, All you do is multiply it by 250. All right, so if you need to go back and listen to that again, you can rewind it and listen to that again. So once you get that, you are at step 5. Go check and see what your question was again. What is the surface area of the smaller solid? Okay, so we're looking for surface area. I'm going to do SA. The surface area should have been 160 square millimeters. So that was your answer for that one. Those aren't so easy problems. Long and involved. All right, now we're going to use the scale factor to find capacity. A bottle that is 10 inches high. Okay, so I'm going to draw. This is going to be this little tiny bottle. And it is from here to here. It is 10 inches high. All right. It holds 34 ounces. All right. 34 ounces is what it holds. All right. The sandwich shop, shown at the right, is shaped just like a milk bottle. To the nearest 1,000 ounces, how much milk could the building hold? All right, let's think about this first. Let's think about small over large. So the height of the small bottle is 10 inches. And the height of the large bottle is 480 inches. Now, I see that in the picture right over here if you're wondering where I'm getting that from. All right. Well, can we reduce that? Sure. Let's reduce it. When you divide by 10, you just take those zeros off. So you have 1 over 48. All right. That is the scale factor, okay? 1 over 48. All right. The second step. Capacity is kind of like volume, okay? And volume is cubic, right? So let's write that. Volume is cubic. All right, so we're going to take the scale factor and we're going to cube it. All right, we're not going to cube it now. We're just saying in a minute we're going to cube it because we're getting ready to do capacity, and that's like volume. All right, my third step is we're going to take 1 cubed, which is 1, and we're just going to put 48 cubed. We're not going to write what that is yet, okay? So that's volume, right? So I'm going to set it equal to, the number on the top is the small one. That's where the 10 came from. That's where the 1 came from. We got it right here. And the one on the bottom is the large one. That's where the 48 came from. Or 480, I'm sorry. And that was the big bottle. So, this is what we're going to do. How many ounces go in the small bottle? 34, right? And the small number's up top, so we put the 34 up top. Do we know how many ounces are in the big bottle? Nope, we don't know. So I don't know what you want to put. You can put V if you want. You can put X if you want. Q, R, whatever you want to. I'm going to put V because volume and capacity are synonymous. All right, now I'm ready. I can solve this. All I've got to do is do cross products. So step 4, when I multiply V times 1, I get V. And then I'm going to multiply 34 times, I'm going to write this a little bit differently. Instead of putting 34 times 48 cubed, I'm going to do 48 cubed because that's what you need to put in your calculator first. And then multiply that by 34. You always want to do fractions first, exponents first, parentheses first, all that kind of stuff. So 48 cubes. Let me go to my calculator. I'm going to do 48 cubed. So 48, and I'm going to hit this little cube button here. Okay. All right, so I did that. 48 cubed, I'm going to multiply it times 34. So times 34. All right, 3760128. 3760128. All right, 3,760,128. Now this is ounces because we were doing capacity, but up here they said to the nearest 1,000 ounce. All right, so what you want to do is you want to find the 1,000 spot. Everything to the left stays the same. So 3,76. Is this number right here, number 1, bigger than 5? It's not. So the 0 stays the same. Everything to the right, including the 1, turns into a 0. Let me erase those markings so you can see this better. So our capacity is 3,760,000 ounces if we were going to really fill up that bottle with milk. That's how many ounces would fit. All right, last one, you guys. You got this. A marble paperweight shaped like a pyramid weighs 15 hundredths of a pound. How much does a similarly, I don't really like that word, it's a tongue twister, a similar one, shaped marble paperweight weigh if each dimension is 3 times as large? All right, so think about that one for a minute. All right, so the only thing it really tells us is it's 3 times as large. So you don't really know what the first one is, but you know whatever the first one is, and this is not a pyramid, I'm just drawing a picture. Whatever the first one is, the other one is 3 times as large. So there's your scale factor. 1 representing the first one, because if you multiplied that times 3, you would get 3 times as large, over 3. That is your scale factor, and it was kind of hidden in there. Okay, so that was actually the small paperweight over the large paperweight. So what we want to do with that is we're talking here about weight, capacity, ounces in the other one, right? This is weight, how much something weighs. So that's kind of like volume because it takes up all that space. So for step number 2, you're going to take the 1/3, which is the scale factor, and you're going to cube it. So 1 times 1 times 1 is obviously 1. And we can handle doing 3 times 3 times 3, right? 27. All right, so now we've got something to work with. All right, step 3, we're going to take that 1 over 27 and we're going to set it equal to, what else do we know? We know the little bitty baby marble paperweight is 15 hundredths of a pound. So that's the small one. So I'm going to put 0.15 on top. And we don't know the weight. I'm just going to put W. We don't know the weight of the large one. That's the one they want to find out. How much does a similar shaped marble paperweight weigh if each dimension is 3 times as large? Here we go. Simple little proportion, right? So 1 times W is W. And then plug into your calculator 27 times 0.15. All right, you should have got 4.05. Go back and look. What is this? This is pounds. It's not ounces for this one. So that is the weight. All right, you guys, I hope you have a good day off tomorrow, and I'll be seeing you soon. Bye.